Hello, and thank you for joining our Milestone Moment webinar. I'm Timon Sloan, the VP of Marketing and Ecosystem with ONF, and today I'll be your host for this webinar highlighting a milestone moment for ONF and for the open networking movement. ONF has achieved remarkable results in driving transformation in the networking industry and a move to open disaggregated systems based on SDN and open source. Today we want to share our most recent achievement and to put this in context with the journey that has led to this result. We have a great agenda for you, and without further ado, I think we should get started. So leading off today will be Guru Palekar. Guru is ONF's Executive Director, as well as Executive Director of Stanford's Platform Lab. Guru has led our remarkable journey that brings us to today, so he's the perfect person to lead us off. Guru, please take it away.
So thank you, Timon. And yes, it's my pleasure and honor to be able to share this big announcement on behalf of this great team and the great community that we have been part of. So what is the big announcement? So the ONF has now open sourced all of Ether and all of its component subsystems. As probably you all know, Ether is this operational complete solution for 5G with connected edge cloud as a service. And its component subsystems include SD-RAN, which is an ORAN compliant RAN implementation, SD Core, which is CUPS compliant 4G, 5G mobile core with programmable data plane and programmable control plane, SD Fabric, which is our data center fabric, which is again cloud managed and with programmable control, and P4 programmable data plane. And finally, ROC, which is runtime operations and control platform. In the industry, this is popularly called a service orchestration. So what is important is that on one hand, all these component systems make up Ether, and Ether, as I mentioned, is an end-to-end complete 5G with connected edge cloud as a service solution. But each one of these component systems in its own right is a very important platform or a system that can be used in that domain to bring a lot of value to that community and that part of the industry. Now, I want to take a minute to highlight the key attributes of Ether and the component subsystems. So Ether, again, I'm repeating myself, it is the private 5G with connected edge cloud as a service. It is end-to-end complete solution that is operational. Now, for Ether, as well as all the component subsystem, one of the most fundamental attribute is they are software defined, and they provide programmable control plane and programmable data plane. And in some cases, it is programmable P4 based programmable data planes. Okay, and then each one of these component in Ether is also feature complete to be able to realize what we call minimum viable product that somebody in the community can take and run with it and productize it. Moreover, each one of them is cloud native as well as cloud managed. So it can be offered as a cloud managed service in its own right. As I mentioned, all of them are production ready as well. And they are based on, or they leverage CI/CD and GitOps tools and practices. And as a result, they also have been operationalized in a small global network. So we have been operating Ether as a service for close to 2 years, and all of these component systems are part of that operational system. And as a result, they are relatively matured, production ready, and that is something community can use and build on. So yes, so naturally the question is, what is the big deal, or what is the significance of this particular announcement, or the fact that ONF has now open sourced all of this, and what is the big deal? So let me take a couple of minutes to summarize that. So I think the most important thing is we believe it is the beginning of a new era for 5G, next G, and edge, in terms of realizing the full potential of these technologies or these solutions for enterprise digital transformation and industry 4.0 transformation. So imagine that today, if you want to create a private 5G network with edge computing, you can literally take Ether and deploy it and operationalize it with relatively pretty minimal effort. On top of that, if you want to build applications, you are able to do that as well with relatively minimal R&D investment, as well as you can do this and take it to market very, very quickly. And the same thing is true for not only for the applications and the whole solution. If there is an idea or an innovation that you have, you want to do some XApp so that you can do RAN optimization better, or you want to manage your data center fabric in a more optimal way, you are able to take that innovation and put it in the context of this larger end-to-end system. And again, with minimal R&D investment, you can take it to market very quickly. And that is a big deal. And that is why we think this is the new era for 5G and edge. Another way to say the same thing is that today, if you want to build a 5G network, especially for enterprises, or build 5G with edge cloud, you may end up spending close to $50 million or more, and it may take several years to create a solution that you can take it to the market. Now, what we are able to do because of Ether and all the component subsystem is we are helping the community, helping any industry partner to take it, and obviously it is already pretty much close to production ready, and then you can add your own custom features, custom applications, and all of that, and very quickly take it to production readiness with minimal R&D investment, as well as very quick time to market. And again, it is because we have an open source with the community that is participating and contributing to maturing of this solution. Ether as a solution, as well as the component subsystem, as I mentioned, they're relatively feature complete. They have number of well-defined APIs, so it is very easy to build application or new features on top of this. And then it is already operationalized and production ready with CI/CD and GitOps. And that is what makes it very easy for the industry or for the community to take it and build on it. And this is how we want to accelerate and broaden the adoption of 5G and edge, and really help the industry realize the full potential of for enterprise digital transformation and for industry 4.0 transformation. And so, as you know, ONF has always been committed to help the community. And my takeaway message today is to come and join, so that together we can realize the full potential of 5G and edge for industry 4.0 and enterprise digital transformation. So with that, Timon, it is back to you.
Thank you, Guru. That was a great way to set the stage for today and to highlight the magnitude of this most recent milestone and the importance of what's just been open sourced. So for today's webinar, we thought and felt that it would really be helpful to put all this work and the great results in context. This journey itself has been exceptionally important, and the things we've learned along the way are almost as important as the end result. And so to that end, Larry Peterson will be our next speaker. Larry is ONF's Chief Technical Officer and has been instrumental in helping ONF arrive at an architecture that has played a pivotal role leading the industry through the transformation to open, disaggregated, cloud-native solutions for networking. So Larry, please take it away.
Thanks, Timon. So this is really a milestone that's 10 years in the making, and I wanted to talk a little bit about the technical path that we followed and how we ended up where we did. And I've labeled this agile process as an architectural coherence. And what I mean by that is it was agile in the sense that we didn't know exactly where we were going to end up. We were always on the lookout for new opportunities, and we often refactored the system and recharted the course a little bit to get where we had the most traction. But at the same time, we didn't do a random walk. We had a lot of architectural principles that we were applying repeatedly over and over to get us to the point that we ended up. And basically, the software that makes up Ether is the consequence of all of those architectural principles. So I think that a really good way to visualize that is to realize that this whole journey started over 10 years ago. And all that we had really was a mission to disrupt the networking industry with SDN and disaggregation and open source. And at the time, we bootstrapped the process with ONOS, which was an SDN controller. That is where the community was 10 years ago, trying to build SDN controllers. And we set out and believed that we built one of the best SDN controllers. It was highly modular. You would configure just the subsystems that you needed. It was horizontally scalable. You would scale it up to get performance. It basically used the practices of cloud native before anyone was saying cloud native. Also highly available, using the Raft algorithm to give you reliability in the case of failures. And we've tracked the relevant APIs over the years. So from OpenFlow to P4, and on the config side from GNMI and GNOI, basically a real heavy focus on the APIs. But ONOS was a low-level system. It really wasn't usable in and of itself. And so what we set out to do was to build a set of use cases. And there have been several of those over the years, and some of them have gotten some traction, but the one that got the biggest traction that ultimately leads us to where we are today, it was Cord, which was central office re-architected as a data center, but the idea was that you could bring up a cloud at the edge of the network, such as in a telco central office, and you could co-locate access technology, PON, GPON, and so on, and other cloud applications on the same platform. But again, that isn't a full solution. So what we did is we, again, created a set of use cases. And one of them pointed in the residential direction, one at enterprises, and one at the mobile use case. And basically what we were trying to do was set up a virtuous cycle where we would enhance the use case and we would take the knowledge we learned and put that back into the underlying platform. And that proved to be a theme that we repeated over and over again. And in fact, what you could think of as Cord is as an umbrella platform that captures the best practices of the time in how you support many different flavors of that platform. While for a while we kind of bordered on trying to straddle the fences, should we go the open stack VM route, or should we go the Kubernetes, Docker, cloud native route, it became pretty clear after iterating on this process that we needed to head in the cloud native direction. And so Cord jumped on board wholeheartedly with that tool chain. Now, the other thing that happened here is as we built out Cord and as we gained experience, we discovered that what started out as a very small subsystem just to get us going took on a life of its own. And so one of the other strategies or tactics, I guess is better to say, that we started to use here was that we would find those subsystems and we would capture them and we'd turn them into standalone systems that could be deployed on their own right. So Trellis is a great example that got a lot of traction and a lot of adoption, but it basically was the switching fabric that was the backbone of the Cord edge cloud. And that is a process that repeated over and over again. As we started to push harder in R Cord and E Cord and M Cord, for example, we carved out the core with OMAC and the RAN with XRAN in the case of M Cord. XRAN later became ORAN, and ORAN, as you probably realize, is now the foundation for what we're going to do in the RAN side. But this practice continued over and over, and we iterated and we got smarter and the platform got better and better. And finally, we got to the point that we got traction with the operators in a way that they said, we're now ready to start trialing this and potentially deploying it. And that happened first with R Cord. And the system got rebranded a little bit. It's SDN-enabled broadband access. So it's the broadband case, it's the R Cord use case. But what's really important here is that we pulled forward the platform from Cord, which was cloud native already, but had only been used in proofs of concept. And now we brought it up to speed in the sense of making it full featured and supporting, in the telco case, the various FCAP requirements in terms of performance and security and fault tolerance and so on. So again, the lesson is that we continued to accumulate our best practices and knowledge in this cloud native platform that is the foundation of SIVA. And in the same way that we recognized that we had a very valuable subsystem, we found out that we discovered the very valuable subsystem here, which was Volta, which is the virtualized OLT. And that even today has a life of its own and is being adopted. So this all brings us finally to Ether. So sort of obviously, Ether is the end result or the continuation of MCORD. It's the 5G connected edge cloud. But it also has a little bit of roots back to eCord, which in and of itself didn't get a ton of traction, but we learned a lot about what it meant to support edge enterprise deployments of edge clouds. And that expertise was pulled forward and is actually shows up in various places, not in software, but in the understanding of how to build out Ether. The platform, again, is the core thing here. And the platform that started out in Cord and got enhanced in CEBA is basically the same platform that got pulled forward into Ether. And again, it got enhanced and made complete. It now basically, you bring up an Ether pod and you're supporting a set of cloud native workloads. And those workloads are managed as a cloud managed service, just like any other cloud managed service. It's got a full featured CI/CD pipeline for continuously integrating the new features that get deployed. The operators deploy the configuration of the system through GitOps practices with configuration of code. And there's a full closed loop runtime control API that you can both monitor what's going on and you can control it as well. So the other thing that happened here, that's sort of the umbrella and the platform, is now we do support a set of cloud native workloads. What are those workloads? Well, the first thing we did is we needed a workload that supported the switching fabric. And so we pulled Trellis forward and refactored it and repackaged it as SD fabric. We pulled the SD core workload forward. Again, it's a Kubernetes workload. And we built out the SD-RAN workload. So this is all to say there's a set of cloud native workloads that run on a cloud native platform, which is Ether. And all the practices that go into turning that into a managed service is really the culmination of 10 years worth of work, building out disruptive, disaggregated SDN-based solutions in the networking space. So with that, let me turn it back over to you, Timon, and we'll hear more about those components.
Yeah, thanks, Larry. So now that Larry's had a chance to share how the architecture came to be, Saurav, ONF's VP of Engineering, will help us understand the major components of the system that make up Ether. Each of these components is groundbreaking in its own right, and each has been separately consumed on its own. Saurav will help us understand these piece parts that power the remarkable Ether platform. So with that, Saurav, please take it away.
Thank you, Timon. So I will talk about SD Fabric, SD Core, SD-RAN, these three components, and then my colleague Oz and I will bring it together, show you how it comes together in Ether. So the first thing that you see on this slide is that, we're talking about SD something, right? And SDN, the core principle of SDN being that the software is pulled outside of the box, and from outside the box, it manages and controls a set of underlying hardware or data plane. So we see that in SD-RAN, where the software outside the box is the near real-time RAN intelligent controller, the NRT RIC, and it manages a collection of RAN nodes, whether they are CU, DU, monolithic E node Bs or G node Bs. And the interface between the RIC and the RAN nodes is the ORAN standardized E2 application protocol and E2 service models. We see that same pattern in SD Core as well, where the data plane, the actual user plane tunnels or user bearer plane is manifested in the user plane functions or the UPF. And the collection of UPFs are managed by the mobile core control plane, whether that's the 4G LTE control plane or the 5G standalone control plane. And again, the interface between the control plane and the user plane functions is the 3GPP standardized PHCP protocol. And again, the pattern repeats when it comes to the fabric. So again, now you have a collection of programmable switches, whether they're hardware or software switches. And then outside the box, you have the fabric controller. And again, the interface between these two is P4 runtime and GNMI. So this is the pattern that repeats, and that's where the naming, the software-defined RAN or core or fabric comes from. So now I'm going to spend a little bit of time giving you an overview of each of these projects, and then they have a reference to several places where you can go and learn more and get involved. So let's start with SD-RAN. Now the focus of SD-RAN, of course, is this near real-time RIC, the RAN intelligent controller outside the box. And we have built this in a cloud-native microservices architecture. You heard from Laddie about ONOS. Now, the second generation of ONOS is micro ONOS, where all the microservices perform different functions and collaborate with each other using gRPC interfaces. So the first thing that you see in this picture, and I don't have the time to go into the details of every microservice, but if you're interested, here is a link that does spend a lot of time talking about each of these microservices. The first thing to observe over here is that communications outside of the RIC, whether it's to the RAN nodes using the E2 interface, or whether it's to a non-real-time RIC from the near real-time RIC to the non-real-time RIC through the A1 interface, or to a service management orchestration engine, there is the O1 interface. All of these interfaces are standardized interfaces coming from the ORAN organization. But internal to the RIC, we have made certain innovations. So whereby this interface, the E2 interface, uses an interface description language such as ASN1. Internally, we convert that into protobufs and gRPC messages between all of our microservices. What this allows us to do is to offer software development kits, SDKs, for applications to work on in different languages, whether it's the Go SDK or the Python SDK, or in the future, other SDKs that make it easier, make life easier for applications to interact with the core services of the RIC and with the RAN nodes. So if you would like to find out more about the micro ONOS near real-time RIC, please take a look at this, this link. But that's not all. In SD-RAN, we don't stop at just the work of building the RIC platform. What we do then is work with our partners to develop XApps on top of these two SDKs. So we have worked with Intel and Facebook and AirHop and Remedo, as well as developed a bunch of applications ourselves for different use cases, and then integrate again with a variety of RAN platforms, whether that's 4G or 5G platforms coming from different commercial vendors, or even on a full-fledged RAN simulator. And in order to do this work, to integrate from app to controller to the RAN nodes, we have developed, we have actually used some standardized service models that come from ORAN, or also we have developed pre-standard service models that we will be looking to convert into the ORAN standardized service models as they develop. So again, if you want to learn more, here is a link to our documentation for the RAN project. Now let's move on to the SD core. Again, the same principles. So we have software that is microservices based and it's cloud native, whether it's the 4G control plane or the 5G control plane. As you can see, these are the network functions that have all been implemented as separate microservices that are cloud native. And what this does is that the 4G and 5G control plane, what's unique about SD core is that both the 4G and the 5G control plane, using the PFCP protocol, can manage a collection of user plane functions, whether they are software-based UPFs or hardware-based UPFs. And I'll talk a little bit more about that, but the best place to go is to use this link to learn more about the SD core project. What's also unique is that in this, we have actually deployed SD core in a variety of ways. So for example, you can imagine that there is an edge cloud and with the user plane function close to the RAN nodes, but the control plane function can be deployed in either a central cloud, which is typically how we do it, or in certain use cases, the control plane can also be deployed at the edge. Okay, so what makes all of this possible is that again, something very unique to the SD core project is that we have developed certain abstractions for the mobile core network. And these abstractions allow us to present a common set of configuration APIs for both the 4G and 5G cores. That's really, really powerful because when you think about it, when you have 10, 20 microservices running as part of your 4G and 5G core, and you have to individually go and configure each microservice or make changes to the configuration at runtime, it's a painful exercise, but what we have done in the SD Core project is that via this abstraction, a network operator can simply create slices or add more subscribers or group subscribers and provision those subscribers to certain slices and so on through one common set of APIs. And then it's the job of SD Core via this config API server to distribute that configuration to each microservice so that the operator does not have to worry about the configuration of each individual microservice. So again, if you would like to learn more about the SD Core project, here's the link to our documentation. And I encourage you to go and take a closer look. So finally, I would now like to talk about SD Fabric. So similar to SD-RAN and SD Core, all of our software is cloud services, cloud managed and microservice based. So for example, a cloud platform can manage the network fabric as a service, and it's integrated with our CI/CD, our logging, our monitoring and alert systems. And my colleague Oz will go through that in a little more detail next. But again, SD Fabric can be managed as a service. It's completely API driven, uses fully programmable switches, and allows you visibility throughout the network. It can be used for multiple purposes. The main purpose that we use it for today is a 5G workload on top of SD Fabric. So when we connect RAN nodes to this, and as I was mentioning, the SD Core control plane can be used with a variety of software and hardware UPFs. Well, that hardware UPF is what we call the P4 UPF that can be implemented in the fabric switches itself. Okay, and it can be used simultaneously with the software UPFs that are deployed in the servers connected to the fabric. And the final point I'd like to make about SD Fabric is that it offers you fine-grained measurements and closed-loop control with the use of in-band telemetry in the hardware as well as in the servers, all feeding up to an external INT server, which then can provide feedback into the fabric controller so you can take actions upon the results of these fine-grained measurements. So as I was mentioning, that the fabric in itself is actually quite scalable and redundant, but allows you a lot of flexibility in how you deploy it. So you could start with probably a single switch in a minimal setup. If you wish to then move it on to high availability, then you can deploy a pair of switches. And in case your deployment needs to grow into multiple racks of servers, you can actually extend that fabric at runtime to involve spine switches and more leaf switches. And this is a capability that SD Fabric provides to anyone who wishes to deploy, start small, and then scale up their deployment. So bringing these things together, as I was mentioning, SD Fabric and SD Core can be run at the same time. The main workload that SD Fabric offers today is that 5G based workload where the user plane function for SD Core can actually be run in the P4 switch. And so traffic from the base stations for the mobile users can go through the P4 UPF and then to edge applications or onto the internet. Or simultaneously, you can have traffic from other user elements go through the same switch, but instead of a hardware UPF, it can go to a software UPF, which we call the best UPF, and then back to the switch and again to the internet or edge applications. So let me give you a brief glimpse of how this looks like in the stack. So here's your SD Core mobile core control plane, and using the PFCP protocol, and which talks to a PFCP agent that is part of SD Fabric. What this PFCP agent here thinks is that it is working on a single UPF. the PFCP agent has this imagination that your RAN nodes are connecting to a UPF and then on to edge applications or the internet. So this one big UPF idea then goes to SD Fabric, and SD Fabric is the one that is aware that is there a single switch out there or a pair of switches or an entire fabric. And it takes the simple single UPF abstraction and then ensures that the rules are correctly populated in according to the topology where this is deployed. So again, if you would like to learn more about this, here's our link to our documentation for SD Fabric. And in fact, I'm going to leave you with a collection of documents where you can learn more in a white paper, or you can visit our documents or videos that we have for various community participation things that we do. And we really encourage you to get involved. And preferred means of communications for each of these projects is our community Slack channel or our mailing list. Thank you.
Thanks, Saurav. That was great. So great overview of the major components and great lead-in for Oz, who's the VP of R&D and Mobility for ONF. Oz, please take it away.
Thanks, Simon. So you've heard before, Ether is effectively ONF's open source platform for private 5G with edge cloud. And towards this end, Ether uses SD-RAN, SD-Core, and SD Fabric as its component systems. And Ether has been architected to be cloud operated and be consumed as a cloud service. And with Ether, our foundational starting point has been to make 5G a solution that is simple to consume for the enterprise, a plug-and-play solution, if you will, just like Wi-Fi, and augment the standard 5G features with unique features that our software-defined networking DNA brings. And Ether is flexibly layered on enterprises' existing edge cloud preferences. So as such, it can run on its own virtual cloud platform or on any one of the hyperscaler edge cloud and hybrid cloud solutions. And it can even run on enterprises' own managed Kubernetes. Now let us see how Ether really leverages SD-RAN, SD-Core, and SD Fabric to deliver the private 5G with connected edge cloud service. So for this, consider now an enterprise that is going through Industry 4.0 transformation using enterprise applications. So these applications empower the automation of manufacturing processes and machinery. And as such, they need connectivity to a variety of devices on-prem. To this environment, we bring in Ether. And Ether uniquely enables a software-defined 5G and is distributed across the edge and the central cloud. Towards this end, it has its own Kubernetes engines, as well as hybrid cloud management tooling to centrally manage all clouds. And as I have mentioned just now, it is possible to replace these with commercial solutions from hyperscalers. But at the edge, running on Kubernetes, we have SD-RAN that gives us a programmatic telemetry collection and associated control of the RAN. We have SD Fabric that similarly gives us telemetry collection and associated control of the edge cloud fabric. We have also one or more UPFs of the SD core, realized in hardware or in software, providing us with local breakout with programmatic network slicing. And for 5G connectivity, Ether uses pre-integrated small cells that are either disaggregated, compliant to the ORAN architecture, or that are monolithic. But either way, these small cells support ORAN's E2 interface and ORAN specified and also pre-standard designed service models to ensure optimal RAN control for private 5G connectivity. Ether's central component includes SD Core's control plane for 4G and 5G that has the capability to centrally control UPFs across multiple edge locations, potentially spread across different enterprise sites around the globe. Now, the central component also includes Ether's ROC, the runtime operational controller, that has the capability to configure and control the component systems in runtime towards a top-down and end-to-end coordinated control of the 5G connectivity. ROC is developed using a microservices architecture and has been designed to be extensible from day one. This means that a solution provider may easily update it so that it can configure and control additional components, for example, the enterprise Wi-Fi. The open source Ether release has ROC configuring and controlling mainly SD core today, as you've heard from Saurav. Future releases will have it control and configure SD Fabric and SD RAN as well. ROC also provides northbound interfaces on which we have developed operator and enterprise portals with which the parties can monitor, troubleshoot, and manage 5G connectivity. This includes subscriber management, access control, quality of service management, and network slicing management. And we have also architected ROC to support AI and ML-based top-down and end-to-end closed-loop control applications that use event correlation and automated reaction to those events to optimize customer experiences and potentially simplify operations. And Ether also exposes highly abstracted 5G connectivity APIs to enterprise solutions. I will talk about these APIs in just a minute. So with Ether, the community is really getting an open source platform that is significantly greater than its component systems. Let us now take a look at Ether's multi-cloud stack. We naturally start with the infrastructure on-prem and in central cloud. For each cluster in the virtual cloud, we have cluster management, namely Kubernetes engines, with necessary network interfaces, accelerator supports, and configurations, as well as VPN-based secure interconnect components. Running centrally, we have management of all clusters in the virtual cloud. This includes provisioning of all infrastructures, as well as IP management, and multi-cluster control and configuration. And layered on all of this, we have all of the Ether component systems that enable 4G and 5G connectivity, namely SD-RAN, SD-Core, SD-Fabric, and the ROC. Next, we have the operational tools, monitoring, logging, and alert platforms, and portals that allow enterprises to customize and operators to control and maintain the network. And running on top of all of this, we have our CI/CD and GitOps tool chains. And of course, Ether's virtual cloud platform can also host Industry 4.0 platform and applications if so desired. The private 4G and 5G connectivity that is provided by Ether is leveraging the CBRS spectrum in the US. So a third-party operated SaaS server completes the stack. And as I mentioned before, Ether can also run on hyperscaler services. And we have already confirmed Ether operation on Google Cloud's Anthos and on AWS. Azure Arc integration is a future study item. Let me now introduce the tooling we have to operationalize Ether. So over the last 2 years, we have been building a very sophisticated CI/CD pipeline for Ether that enabled us to bring automation to building, testing, and deploying all of the Ether components continuously. This CI/CD pipeline is not only for Ether. If one wishes to consume any one of the component systems in isolation, they can readily use this pipeline for automated integration, development, deployment, and operations. So on this slide, you see our CI pipeline, where you observe how developed code components are maintained in our repos, how unit tests, component tests, and license tests are conducted, how code is merged, and how deployment repos are updated accordingly to enable system-wide tests on a staging network. One thing to note is that we have also incorporated GitOps in our CI/CD tooling. The Ether operations team establishes and updates infrastructure and application configurations towards automated deployments and maintenance as part of our GitOps tooling. So then the images, manifests, and infrastructure and application configurations are collectively used for the CD portion of our CI/CD toolchain. And in parallel, the automated infrastructure configuration updates empower us to treat our Kubernetes infrastructure as code in Ether. Then thanks to our CI/CD pipeline, we can now deploy a new Ether edge remotely in just a few hours. Our tooling also enables us to maintain Ether operations, handle potential bugs, introduce new features towards a highly performant and highly available solution. I mentioned that Ether provides rich APIs for multiple stakeholders. Let us now go over them. So you've heard from Saurabh with open SDKs provided in multiple languages, Go and Python right now. It offers APIs and libraries to RAN control application developers who may wish to bring in innovative solutions towards automated RAN telemetry collection and control. Similarly, it offers open APIs to SDN and P4-based Edge Cloud Fabric control application developers who may wish to bring in innovative solutions towards telemetry collection, network verification, and control towards enhanced performance, enhanced security, and troubleshooting capabilities. And one can also imagine open APIs for the mobile core towards developers who may want to integrate our solution with platforms and solutions such as SIM and eSIM management platforms, LDAP integration, integration with Active Directory, etc. And these three component systems also expose APIs towards integration with OSS and BSS platforms. We use these APIs obviously internally to integrate them with our runtime operational controller. And next are the system-wide APIs. We expose APIs towards customer portal development. Obviously, we use these internally, but they may be utilized by an ecosystem partner to develop unified portals that allow customers to monitor and control cloud, SD-WAN, and private 5G solutions in a unified manner. And I mentioned about this towards bringing autonomy to the end-to-end private 5G system. We will soon expose APIs towards developers who want to build AI and ML platforms for end-to-end connectivity control and management. These applications would not only result in better overall performance, but would also simplify operations, minimizing the need for human intervention. And last but not least, as I have already mentioned, we expose APIs towards Industry 4.0 application developers. From an Industry 4.0 perspective, this is very important. When you think about it, a potential customer will want a 5G network to enable an Industry 4.0 use case. And 5G connectivity is only one part of this end-to-end solution. And for an overall optimized performance, connectivity and autonomous Industry 4.0 operation would need to be considered together. And these APIs allow just that. So you have heard from Guru that our solution has been operational for the last 2 years as a pilot network. ONF has been the service provider for this pilot network. We have seen our global footprint grow during this time. Indeed, we now operate Ether in about 15 locations around the world and have a number of new sites in our pipeline. Our operations have already achieved multiple nines availability. And in October of last year, we have operationalized a field trial with Deutsche Telekom in Berlin. This is a combined 4G and 5G network with Ether that is fully ORAN architecture based. And it is also a multi-vendor solution. And as such, it leverages both open source Ether components and proprietary components, commercial components from the ecosystem partners. So to wrap it up, with Ether, we are open sourcing an amazing platform that is innovative, highly programmable, multi-cloud supporting, that is feature rich, And that is for all practical purposes, near production grade. And we're open sourcing it at the perfect time. Private 5G is potentially a huge emerging market, and its adoption is starting to pick up now. And with Ether's rich set of APIs, the ecosystem can easily take it, add their own innovations on it, and run with it. So let me pause here and pass it back to Timon so he can introduce the next segment of the presentation.
Thanks, Oz. That was great. To follow up on that overview of the Ether platform, Asim, ONF's VP of Platforms and Solutions, is going to highlight where this work has had impact and has been adopted. And also to talk a little bit about where we expect this work to address some of the larger business opportunities going forward. So with that, Asim, please take it away.
Thank you, Timon. From its very start, ONF has been guided by the fact that we want to create this impact to our industry, and we have used that to steer our activities and groundbreaking innovations. While impact can be measured using several metrics, the one our board and we tend to gravitate to is the commercial adoption and deployment of our open source artifacts by network operators, cloud operators, and large enterprises, as well as the vendor ecosystem that services them. In the next few minutes, I want to share how far we have come over the past 10 years in this regard and what opportunities lie ahead for our community to benefit from the work being done at ONF. Next slide, please. This graph conceptually illustrates the pace of adoption of ONF artifacts over time. As you may notice, there are three distinct phases where you might want to let me tell you when to click, please. You may notice three distinct phases where pace accelerates. While it is obvious that the adoption picks up as the artifacts mature in capability and reliability, it was not as obvious when we started this journey that adoption would be proportional to the readiness of consumption of these artifacts and the completeness of the solution, including, as Oz described, the operationalization and the CI/CD capabilities. Next click, please. As Larry described earlier, when we released the ONOS SDN controller and later the core architecture, we saw that a handful of forward-looking operators started to use it for their SDN explorations and initial forays. A few vendors consumed these artifacts to build their products that competed with incumbents, but these artifacts constituted a rather small percentage of the overall product, and hence maybe the vendors did not make a lot of noise about using ONOS and core and not make it well known. Next slide, next click, please. This started to change as ONF focused on building out subsystems on top of these robust components and delivered what I call component systems like Trellis, Volta, OMEC, and others. And Comcast was the first operator to publicly acknowledge use of the ONS artifact Trellis to deliver commercial services in multiple geographies and to thousands of subscribers. Since then, Deutsche Telekom and Turk Telekom have taken it a notch higher by using SIBA Volta in production for their broadband services. T-Mobile Poland has used OMEC for its fixed wireless offerings, and through efforts of vendors like Intel, Redis, Infosys, EdgeCore, and others, ONF artifacts are now commercially deployed in other operators like Geo, Far EasTone, and Telstra. Click, please. As our artifacts matured and became more readily consumable with Ether and its subsystems, the adoption curve further accelerates up, with many in the community getting involved and several large enterprises and system integrators showing interest. One more click. With today's big announcement of all the new platforms and solutions being open source, the multi-billion dollar markets they support, I'm confident that the commercial adoption of ONF artifacts would continue to accelerate. Let's look at the business opportunities being unlocked by these new platforms and solutions. Next slide, please. The 5G and edge computing are two of the biggest drivers of Industry 4.0 revolution that is underway today. There are several analysts who have been very bullish on this market and estimate this TAM to be between 550 billion to as high as 500 billion. This slide shows the analysis of KPMG and Polaris, two of the analysts I described, and it identifies the enterprise verticals like smart manufacturing, smart logistics, smart healthcare, facilities, and other logistical areas like oil and gas and airports, where this biggest opportunity lie in the near term. Next slide, please. Some of the components, subsystems that are part of Ether have applicability beyond the enterprise 5G edge market. We are seeing interest from multiple large players like AT&T, China Mobile, DT, Rakuten, and Intel in the SD-RAN subsystem to realize a disaggregated RAN, which again is a multi-billion dollar market. Dell'Oro estimated the 5G RAN market to be $200 billion in 2024. Click, please. Similarly, the SD-RAN and the PINS projects have the ability to enable our community to address the needs of this hybrid cloud era by building a highly programmable cloud-managed data center and edge fabric. This too is a multi-billion dollar market opportunity. I again invite the community to leverage these free to license open source platforms and to participate in this huge and growing markets. Timon, back to you.
Great, thanks, Asim. So, the remarkable result that ONF has achieved has only been made possible by building a unique organization with a unique approach. And given the magnitude of today's webinar, we thought that we'd like to share some of that background that might be helpful to those of you who might also be looking to build organizations to leverage this work from ONF. So Bill, ONF's Chief Development Officer, has been with ONF from the very beginning and has been instrumental in making all of this possible and creating a unique team. And so Bill, if you would, please take it away.
Thanks, Timon. I appreciate the opportunity to talk about the amazing team we have. Go ahead, next slide. Our original mission, starting back in 2010, 2011, has been accelerating innovation, bringing CapEx and OpEx efficiencies to network operators, and doing that through the leveraging SDN and disaggregation and open source. If you were watching any presentations around this time, you would have found any operator had a slide that looked somewhat like this one, and they all had growing pressure on their business models. The demand for data with mobile devices and video was increasing exponentially. And at the same time, their average revenue per user was at best flat and probably a little bit down. So this was a tough situation, and they could see what was coming, and they needed a different model for building infrastructures and for addressing this. And ONF offered them a way to pursue a different architecture and model, and we became a trusted partner to the operators. Key to that being we're a nonprofit, so without the profit motive, they felt more comfortable being able to share their needs and requirements. And ONF being mission-oriented, wanting to find solutions and drive to operational systems. Next slide. We knew we needed a different type of open source model. Of course, Linux Foundation, Open Infra, and other foundations are very successful in what they do. And they operate with no development team. They manage the projects in their community. They're good at adopting new technologies for their members. And they operate by building consensus in a more incremental way. And they focus on serving their entire community. And that's all great. But we needed something a little bit different. Click. We really needed to have our own developer team. And why did we need that? Well, we needed to drive an agenda for innovation. We needed to break through technical barriers that people saw, barriers being, most people didn't believe that SDN concepts could be applied to operational systems and get the type of scale and performance that you'd want. And so we had to prove them wrong. And in doing so, we had a very transformational agenda. and impacted a lot of existing architectures and business models by pushing these forward. As you've heard, we had a big focus not only on components, but also on working operational systems. And maybe most basic is we chose to serve the end customer, meaning the network operators, and really make sure that the work we were doing served them well. Next slide. We had a little trepidation at the beginning. Could we really staff such an organization? And some concerns we had. Of course, it's always hard to hire in Silicon Valley. At the time, there wasn't a lot of SDN talent to be found, especially in the Valley and in existing companies. We're a nonprofit, and question is, who wants to work for a nonprofit? There's no equity. And we also worried about retention. Were people just going to come in, learn SDN, and then move on to their next favorite for-profit company? But in reality, we had a lot going for us, and just starting with having top leadership in SDN, the people who invented SDN and who were creating this new set of architectures and industry, Nick McEwen, Guru, Larry, amongst others. So that provided a lot of draw. And we were also fortunate to have a handful of what I would call A-team type of developers, which formed a core development team around which we could add more A-team members. We're also fortunate to have some very strong corporate partnerships with companies like Intel and Google and NTT and EdgeCore. And the work that we were doing with them was very compelling to a lot of developers. And then finally, and maybe most important, is the mission was very compelling. How many opportunities do you get to make such a big impact on an industry? Next slide. So how we hired, Smart and Gets Things Done. I know it sounds trite. It's the name of a book that inspired me though, and I encourage you to read it. We focused on universities, very well-known universities in the world of networking, who are leading the charge for SDN, and focused on finding the best talent in those universities, people who had a passion for bringing SDN to the mainstream, a lot of PhDs, but we focused on ones who wanted to really build operational systems. And thinking long-term, we created good relationships with these universities and invested in interns. We've had a lot of interns at ONF. Many have become full-time employees. Of course, distributed systems talent was extremely important too. Click. Add to that a touch of corporations, both larger corporations as well as startups, people in those companies that wanted to move into SDN and leverage the skills that they had for networking, people who are passionate about the mission. This brought the best development practices for our development organization and allowed us to keep a very high quality in an operational focus and building out of test automation and CI/CD tool chains. And of course, distributed systems was important there too. Next slide. And maybe most important was building a culture around which these type of A players could thrive. And we had a compelling mission allowing a person to attach to something bigger than oneself and be motivated to really make big changes in the world. We've always had a flexible, flat organization. We've never had a layer of management. This gave us the ability to really get work done without a lot of friction and without building silos, ability to flow developers easily between projects. We've always had a big commitment to solving for really hard problems, aggressive goals, meaningful challenges, and we've also had a history of meeting those challenges, and the success really drives people to want to do even more. We've always had the latest technologies and methods. That's always of interest to engineers. We've fostered a transparency amongst the team. Anybody can ask anything and get straight answers about why we're doing whatever it is that we're doing. And very importantly, a mutual respect. These are people that love learning from each other. It's a fantastically talented set of people. And not only do they love to work together, but they love to hang out together too. It's a great group of people that really enjoy each other's company. All right, so I appreciate having the opportunity to talk about our team. They're amazing. I've loved working with them over the years, and I look forward to more of that coming up. So Timon, back to you.
Oh, thanks, Bill. That was great. So to wrap up for today, I want to share a few closing thoughts, and then we can take some Q&A. There's a Q&A button at the bottom. There have been some questions coming in, and a number have been getting answered live through the chat. But if you have other questions, please feel free to feed them towards us. So, we titled this webinar Milestone Moment because we believe this most recent release from ONF really allows ONF to enter a new phase in its journey. So if you would, Oza, please click to the next slide. So ONF has been through a truly remarkable journey, and you've heard much of that today. It really started way back even with evangelizing SDN and with OpenFlow. I remember OpenFlow? We didn't even talk about that today because that's really all moved towards programmable data planes and P4 and the like. But that was the beginning of it. And through this phase two, we've we worked with partners, largely operators, to jointly fund the development of our platforms, and you've seen the results of that here today, which have been truly remarkable. And then operators began to deploy these platforms into production, and again, you've seen a taste of that today. So with today and with this remarkable moment and what we've managed to open source this month, we believe we're entering a new phase in ONF's journey, a phase to really expand consumption and adoption, as a phase where we want to focus on broadening our developer community and on activating the open source multiplier effect for our projects. So we're really excited. We think that we've reached a natural milestone in the journey towards open networking. We've retrieved results that honestly exceeded maybe our initial expectations. And we think there's lots more to come. And so, with that, we're really wanting to invite all of you and the community to come and engage, and we're going to do our very best to make sure you're successful in engaging with the ONF platforms. Next slide, please. So there are lots of ways you can engage and what you can do next. And maybe there's a class of activities that are more around consuming the projects and the platforms. I think that we're already seeing questions in the Q&A about building 4G and 5G networks, and so deploying 4G, 5G, private 4G, 5G, or in public network configurations and the like. These platforms are ideally suited to build upon. Also, for those of you interested in programmable fabrics and deploying P4 programmable fabrics, the platforms are ready and available and are production grade and ready for you to use. And there are also many ways to extend and build on the work. And just a few thoughts, supporting new silicon targets, port SD fabric and pins to new switches, and extend the work to IPUs and DPUs. SmartNICs is a very hot and up and coming area. Build new RAN components, or bring in these components into our solutions. And so, RU, DU, CU, all of the ORAN open architecture components are compatible with SD-RAN. We have a live ongoing trial hosted by Deutsche Telekom that we're continuing to extend, and we are actively looking for community members who want to engage more and bring in more components. And building XApps on top of SD-RAN. Again, these are available to come into the DT trial, and an area that we really want to explore and drive forward. Building Industry 4.0 applications on top of Ether. You heard about the amazing set of APIs and the work that we've done there from Oz, and now's the time and the opportunity to come and start to really leverage 5G and Edge for this next class of intelligent applications for Industry 4.0. And NextG research. If you're interested in 5G and NextG research, leveraging Ether as a whole or its components, SD-RAN, SD-Core, SD-Fabric are great ways, and we believe the best possible platform to be able to build upon. It's it's a fully integrated, cohesive platform that's easy to bring up, but it's also, I mean, really importantly, the most programmable platform, the most open platform. It's designed to be easy to customize and to extend. And so with that, if you're interested in exploring extensions and pushing things forward, we believe that you absolutely need to give these platforms a try. Next slide, please. So just in closing, I want to say thank you. We have an amazing community. The work we've done would not have been possible to this date without these companies and frankly many more as well. It's been a unique combination of operators and vendors and integrators, and truly a pleasure working with all these different organizations. And just thank you, and let's keep at it. There's more to do. Next slide. So with that, that brings our prepared content to a close for today. I want to invite all the other speakers to turn on their videos and come back, and then we can field some of the questions that are coming in to Q&A. And maybe we could stop screen share as well. Great, thanks. So I see one sort of high-level question that maybe would be good for you, Guru, that is around Ananke. Ananke didn't get mentioned today, and Ananke was sort of a commercial spin out of ONF. You want to say something about Ananke, Guru?
Okay, so first of all, I'm not surprised about the question. The second thing is that first and foremost, I want to clarify that these are all ONF's open source platform, and today we were representing ONF in talking about these platforms and the ONF journey. Having said that, again, I want to remind people that Ananke was created really to take ONF's open source platforms, continue to contribute to those open source platforms, get them production ready and all of that, and offer them commercially. And Ananke and ONF always expected that there will be many more companies that will take these open source platforms and build commercial solutions on top of that. And that continues to be the case now. Going forward, of course, you should expect the Ananke team to continue to contribute to these open source platforms. And stay tuned. We will share more about Ananke soon. Thank you. Simon, hope that answers the question.
Good. Well, maybe we'll get a follow-up question if there are remaining thoughts there. Maybe a related question in some ways is, there's some notable things getting open source now. So why are these components getting open sourced at this point in time?
So I guess, again, a good question. Whenever good things happen, you always wish, why didn't they happen sooner? So that is good to know that people think it should have happened sooner. But again, everything, it takes time. So first of all, with any open source platform, if you look at it, it is best to have certain level of maturity to the platform before you open source it and invite the community to use. If you do it prematurely, community tries to use it and then gets turned off, and that's not necessarily a good thing. And so if you look at what has happened with Ether and some of the other components, we have been working with our community. We had created something called member-only license. And as you saw in Timon's last but one slide, that there was a set of companies and the community that we have been working with. And now that these platforms are relatively mature, they are production ready, we feel confident that community can use and build on. We thought now is the right time to open source it, and community will have a very positive experience using these platforms and building on it. I don't mean to suggest that these platforms are done. There are no new features or capabilities that can be added. In fact, as Timon mentioned, there is a lot of work to be done with these platforms, on top of these platforms. And we really hope that the community will join and do that. But now they're matured enough, they have certain feature completeness that it makes sense for us to open source it and try to engage the broader community to build on it.
Good, thank you. There are a couple of questions that have come in that have mentioned Magma, and a couple of questions that are asking about sort of different features in SD Core. Maybe Oz, would you share your perspective on the difference between Magma and SD Core, or Saurabh as well?
Sure. Magma is a great open source mobile core platform that is under Linux Foundation right now. So far, the Magma solution is focusing on 4G and with support for narrowband IoT. There is a roadmap for 5G, but it doesn't support 5G as of today. It is also meant to be consumed in a way, even though it is microservices based monolithically, whereas, that is the high level overview of Magma, whereas SD Core from day one has really focused on getting a stable and scalable 5G, open source 5G solution that can run concurrently with 4G and that can also be consumed either as a whole or some components can be replaced by some proprietary components, because everything, even the internals, are 3GPP compliant, all of the interfaces. So at a high level, those would be the differences. But I'll repeat what I said in the beginning. Magma is a great solution, and there are deployments that are Magma based that have been very successful as well.
Good, thank you. I've also seen a question about spectrum support, frequency support, and a question about 4.10 megahertz, which I think is some repurposed spectrum that's starting to become available. Oz, you want to maybe say a little bit about if somebody wants to build a custom solution like that, if that's possible?
So in general, I don't see why not. I mean, it really boils down to the development of the necessary RAN pieces, the small cells or the base stations, as well as the end devices that will enable the communication. So once you have that, once you have the RF front ends that support both the user equipment and the RAN, you should be able to use a 3GPP compliant mobile core for end-to-end connectivity. But those pieces have to come to life first.
Good, thank you. So, and let's see, a question about, I don't know, actually, I don't know this acronym, TVWS. But whether the software can implement such a system using 5G. Any of you know that acronym?
No. Can you repeat the acronym?
It was TVWS. If,
the TV white space. So that is again another another spectrum, if you will, that is made available, especially in the US. Again, if you want to run a 3GPP compliant 5G network on a specific white space that is available in spectrum, as long as you have the radio pieces on both ends, the small cells, base stations, and the user equipment, you can potentially have this solution run and support that. Now the TV white space may, again, I'm not an expert on it, but it may require, just like CBRS, some sensing, etc. And that may actually have some features that may need to be added on the mobile core end. But otherwise, you can potentially use this as the seed to develop a solution like that.
Good, thank you. So, I mean, I guess, ONF solutions really focus on the software, and the RAN components have come from the community, and that's kind of another way of, any RAN components that can be sourced, can be integrated and used. And, with that notion of focusing on the software, there's a question about Kubernetes and whether we can support Fedora and whether we can support other cloud environments, any restrictions on how and where you can deploy.
So as I mentioned in my part of the presentation, we have already tried, in addition to our own Kubernetes engine, we have tried Google Cloud Anthos and AWS Kubernetes engines. Ether without too much effort, we could run Ether on those. So now, obviously, those solutions could be expanded. So there are some requirements. For example, specifically some network interfaces, container network interfaces like Multus and SRIOV need to be supported by the commercial Kubernetes engine. So as long as the necessary kernel support and the network interface support is there to run 3GPP mobile core and ORAN compliant RAN software pieces, then we can run Ether on any of the commercial Kubernetes engines.
Good, thank you. So a question about DUCU software and open source. You know, is there open source DUCU software that's in production mode now?
Production mode is the short answer is no, but there are lab grade solutions. So open air interface is one that we internally within ONF have used and have developed some early ORAN solutions that went past this standardization. So from that end, OAI has been very, very useful for us. But having said that, taking that and using it in a commercial setting is probably today not possible. It doesn't scale. There are certain issues that need to be hardened, etc. And to my knowledge, the minute you say open source, a commercial grade open source RAN stack is not available today.
Right, and just sort of a follow-up color there is that in our deployment and with the DT trial, we're using commercial CU and DU, not open.
Yes, we are. We are.
Right.
So let me clarify. So in the DT trial, there's 4G and 5G solutions that run concurrently. The 5G is entirely commercial. Yes. So the radios, the RUs come from Foxconn. The layer 1 is Intel's FlexRAN, and layer 2 and 3 that gets spread across DU and CU come from Radisys. All of them are commercial grade. Mm-hmm. And the integration is commercial grade as well. Now, the 4G part, we have actually created using Etus software-defined radios and open air interface, a solution. So we do provide 4G connectivity in the courtyard, but obviously because we are using open air interface, our scale is very, very limited. So we do support maybe a couple handsets at a time with 4G.
Good. And a question about what's sort of the minimal, what does it take to get started? So, we were just talking about the full DT trial, but maybe Saurav, you could share, if somebody wants to just test the waters and see, how easy is it, what does it require, hardware-wise, RAN-wise, the like?
Sure. If you visit the documentation links that I had shared as part of this presentation, probably the easiest way to get started is to use something what we call Ether in a box. And what you will get out of Ether in a box is that you will have a RAN implementation, which is actually OAI based. It's not supporting SD-RAN. There is a separate development environment called SD-RAN in a box. And again, that's in our documentation if you actually want to play with the RIC working with a RAN implementation. So for SD-RAN, that's a good place to start. But for the rest, Ether in a box will give you a RAN implementation plus our mobile core, plus the Ether aspects of the runtime operational control. So that's the best place to get started, to just try it out on your laptop or a VM that you have deployed somewhere. And then what we are working on right now is that same environment can actually, instead of using the OAI based software emulated RAN, you can actually use it with the real E node B or G node B and with real user elements, still keeping the rest of the software, the core and the Ether pieces inside Ether in a box. So we will be publishing documentation for you to do that in the next couple of weeks. And once you are familiar with just trying it out yourself or trying it out with real RAN, if you are looking to actually do more, then I encourage you to reach out to us on the Slack channels.
Okay, terrific. Thanks. Well, I think that this naturally brings the webinar to a conclusion today. And I think actually that was maybe a good question to end on, next steps and how you can get started if you're out there and you're wondering and curious, about what to do next. I want to thank all of our speakers. I want to thank the audience today. Thank you for participating. For those of you who sent in the questions, especially as well. We couldn't do this without the community, and we are really excited to take the next steps. And please reach out to us. We're happy to help, and we'll do what we can to help you be successful, engaging with us and engaging with these exciting projects. Thank you.
And I want to also thank Timon for leading this webinar and seeing it. So really appreciate it. And yeah, thank you all, and hope to see you soon again. Thank you. Bye.